We are going to get some notes from 9.1 done today, and it involves the nth root functions. Okay, so you guys are familiar with some roots, like the square root, cube root, so on and so forth. We've encountered that a little bit so far this year, and definitely last year. We're going to talk about what they look like as exponents and how to go from one format to the other. Little helpful thing to remember, when we talk about rational exponents, that's sort of a fancy way of saying that the exponent is a fraction. And so we have a very generic situation here. We have some either letter or variable, which we'll call a, and it's raised to the 1 over n, where this is just some number. So it's raised to a fraction. You can see that we have a rational exponent. That is equivalent to taking the nth root of whatever a is going to be. So basically, whatever number you have in the bottom here of your rational exponent tells you what root to take. So it's pretty simple once you see how it works. One thing that we want to be comfortable doing is rewriting different expressions with a radical symbol instead of a rational exponent. So, for example, if I have x, y all raised to the 1/2, because this is a rational exponent, that means it is equivalent to the square root of xy. Now with square roots, you don't have to put a 2 in that little nook part. It's implied to be a 2 if you don't see it there. Square roots are pretty popular in terms of the types of roots that we see. Okay. By the way, radical just means use a root. So pause the video, go ahead, try the next two, and then play the video to see how you did. Okay, so hopefully you tried this next one. If I have m to the 8 over 24, one of the first things that I notice is that 8 over 24 could be reduced to 1 over 3. And because that's a rational exponent with a 1 on top and a 3 on the bottom, I know that's equivalent to the cube root of m. So notice I put a little 3 in the nook. On the next one, hopefully you recognize that you're again taking the cube root of x minus 7. So pretty easy. Now we're going to work in reverse. So on the first one here, I notice that there's no number in the nook, so it's implied to be a 2. It means a square root of x minus 3. And we have to rewrite this with a rational exponent, meaning use an exponent that is a fraction. So I'm going to take x minus 3, and I'm going to put in parentheses because the entire thing is being square rooted. Then the entire thing needs to be raised to the 1/2 power. Go ahead, pause the video, try the next two. All right, on the next one, we've got 64x to the 6th needs to be all raised to the 1/3 power. But really, we actually could simplify this a little bit more. One thing that I'm allowed to do is distribute that exponent. I can do that here because this is multiplication between the 64 and the x to the 6th. I could not do it up here because of that minus sign. Anyway, so I'm going to distribute the power of 1/3 to 64 and also to the x to the 6th, which becomes a 6 over 3. I can simplify this even more. 64 to the 1/3 means the cube root of 64, which is actually just 4. And then 6 over 3 is an exponent of 2 on x. The next one can look a little scary. You have the 4th root of the cube root of 5x. Just take it sort of one root at a time. So I'm taking 5x. I'm going to first cube root it, which means I'm first raising it to the 1/3 power. And then I'm going to 4th root it, which means I'm raising it to the 1/4 power. Now, a power on top of a power like that, you can take those powers and multiply them together. 1/3 times 1/4 is 1/12. Now I would argue that you can leave this answer as it is. Distributing that exponent of 1/12 to 5 into x doesn't really get you anywhere. It certainly wouldn't be wrong. So if you have this, then that's appropriate as well, but I can't evaluate the 12th root of 5. That's not going to be a nice number. So either this one or that one is fine, either or there. But this one up here should definitely be 4x squared. Okay, either one of these will do in that situation. Okay, other things I want you to be comfortable with, and this kind of came up on the previous problem there. If you have a number raised to a rational exponent, being comfortable evaluating that if it's one of those perfect powers. So I'm going to do the top line here and then have you guys try the remaining problems. When I see 25 raised to the 1/2, that's the same as square rooting 25, which is just 5. When I see 125 raised to the 1/3, that's the cube root of 125, which is actually also 5. And 10,000 raised to the 1/4 is the 4th root of 10,000, which is just 10. So go ahead, try the other 3 rows. We'll go over those in class tomorrow. Make sure you have the right answers, but they shouldn't be too hard. So you can pause the video and do those now. Okay. Another thing that I would like you to be comfortable with is the idea that powers and roots, so powers, exponents, and roots are inverses of one another. This means that they undo each other. We learned about that last chapter, how inverses undo each other. So just like you did in the previous chapter, we can find inverses here. And you had a question similar, to these on the last chapter test, but just making sure that we understand this idea. If I have a function here and I want to know the inverse, first thing we're going to do is switch x and y. Next, we have to do some algebra to get this new y value by itself. So first thing we want to do is subtract 3 to the other side. And then divide by -2. So here's the thing. We need to undo a power of 4 to do that. We need to take the 4th root, or you could raise it to the 1/4 power. So it's possible to write your final answer here in 2 different ways. I could have well, this won't be the final answer. We won't be done yet, but I could have the 4th root of x minus 3 all over -2 equals y plus 1, or x minus 3 all over -2 raised to the 1/4 equals y plus 1. Of course, y is not quite by itself yet, so in each situation, I do need to subtract 1. Work this way, ran out of room. So 4th root of x minus 3 all over -2. Then I'm going to subtract the 1 over. Okay. Now, something I should have done back here, I almost forgot. Because I am taking an even root, I really should have a plus or minus when I do that. Okay, same thing with that 1/4 power, although we don't always see it like that. If this had been an odd root, I wouldn't have a plus or minus, but even roots do. So something to keep in mind. And then you have the 1/4 power instead, still subtracting 1 on the outside. When I'm done finding inverses, I always kind of like to check, here I was, I just realized something, guys. I changed that plus sign to a minus sign. What? see, this was good. I went back to check, and I just caught an error. This minus sign was a minus, so then that needed to be added over. Let me tell you how I caught my mistake. I saw this minus 1 in the original, and I knew in the inverse I should see a plus 1. And I didn't, and so I knew that was a problem. Minus 1 on the inside, on the inverse you're going to see a plus 1 on the outside. Here there's a negative 2 on the outside that you're multiplying by. Should expect to see some division by negative 2 on the inside, and I do. I have plus 3 on the outside. In the inverse I should have a minus 3 on the inside. So power of 4 is undone with a 4th root. I always like to go back and just check and make sure that, you know, everything is indeed going to undo each other. Kind of checks my algebra. And like I said, I just caught a mistake that I had made. So not a terrible idea to get in the habit of doing. You can write that as your final answer, or it is acceptable to write this as your final answer. So go ahead, pause the video, try the next one, and when I check this tomorrow in class, we'll see how you did.